Imagine you are trying to teach a powerful language model not to help someone build a bomb or write a racist screed or hack into their neighbor's Wi-Fi. The standard approach today is to hire armies of crowd workers, have them try to bait the model into saying terrible things, and then have other crowd workers label which of two model responses is less harmful. You then distill those tens of thousands of human judgments into a reward signal and fine-tune the model with reinforcement learning. This works, but it has some unsettling properties. The training signal is buried in a mountain of private labels that no human can actually inspect or summarize. The workers themselves are exposed to a steady stream of toxic content, and the resulting model tends to become evasive, refusing to engage with anything sensitive by hiding behind canned, "I can't answer that" responses. Worse, as models grow more capable, it becomes increasingly unclear whether human supervisors can even tell when a model is misbehaving in subtle ways. So a natural question arises: can we get the AI to supervise itself, guided only by a short, human-readable set of principles? This is the question Anthropic tackles with what they call constitutional AI. The core idea is that instead of providing tens of thousands of harmfulness labels, humans write a small constitution of roughly 16 natural language principles. Things like, choose the response a wise, ethical, polite, and friendly person would more likely say. The model then uses these principles to critique and improve its own outputs. Think of it less like training a dog with treats and more like giving a smart intern a style guide and asking them to mark up their own draft. The method has two stages. In the supervised stage, they start with a model that has already been trained to be helpful, though not necessarily harmless. Then they hit it with red team prompts designed to elicit bad behavior. The model produces a harmful response. Then they paste that response back into the context along with a critique request drawn from the Constitution. Something like, identify ways in which the previous response was harmful or unethical. The model writes a critique of itself. Then they ask it to revise the response in light of that critique. They can repeat this loop, sampling a different principle each time, and the responses get progressively less harmful. Finally, they fine-tune the original pre-trained model on these revised responses, mixed with some helpful examples to preserve helpfulness. The result is a model they call RL-CAI that is roughly on distribution for the next stage. The second stage replaces human feedback on harmfulness entirely with AI feedback. They take the RL-CAI model and use it to generate pairs of responses to red team prompts. Then they hand each pair to a separate feedback model, formatted as a multiple choice question. Here is a conversation, here is a constitutional principle, which response, A or B, is less harmful. They extract the log probabilities the model assigns to A versus B and use those as soft preference labels. Crucially, they ensemble over the 16 principles, randomly sampling a different one for each comparison, which they find gives more robust preference signals than using one principle repeatedly. These AI-generated harmlessness labels are then mixed with human-generated helpfulness labels to train a preference model, which then serves as the reward function for standard reinforcement learning. They call this whole pipeline RLAIF, reinforcement learning from AI feedback, as opposed to the familiar RLHF. There is one more clever trick. They experiment with chain of thought prompting for the feedback model, where instead of just outputting a preference, the model first reasons step by step about why one response is more harmful than the other, then commits to an answer. This makes the decision more transparent and tends to improve label quality. But it creates a calibration problem. Once a model has reasoned its way to an answer, it becomes extremely confident, producing probabilities near 0 or 1. These overconfident labels cause the RL training to push the model toward overly harsh, preachy responses. Their fix was wonderfully pragmatic. They simply clamp the chain of thought probabilities to lie between 40 and 60%, which softens the signal enough to prevent the model from collapsing into self-righteousness. The results are striking. On crowd-worker evaluations comparing helpfulness and harmlessness (ELO scores), the RL-CAI models achieve a Pareto improvement over standard RLHF trained on human harmfulness labels. They are roughly as helpful as a model trained purely for helpfulness, but dramatically more harmless. And critically, they are not evasive. Where the older HH RLHF model would respond to a question about whether terrorist attacks can be justified by clamming up, the RL-CAI model engages, explains why such acts are never justified, and treats the user like an adult. They also show a fascinating scaling result. As language models get bigger, their ability to identify harmful behavior in multiple choice format approaches that of a preference model trained on hundreds of thousands of human labels, and chain of thought reasoning closes the gap further. This is the empirical backbone of the whole approach, the evidence that AI feedback is becoming a viable substitute for human feedback on this kind of task. There are real limitations worth surfacing. The Constitution itself was written ad hoc by the researchers, with 16 principles chosen iteratively rather than through any principled stakeholder process. And the authors openly acknowledge this should not be how a deployed system is designed. The method also still relies on human feedback for helpfulness, so it is not fully self-supervised, just self-supervised on the harm axis. The overtrained models exhibit good-hearting, where they start tacking on saccharine boilerplate like, "You are valid, valued, and cared for," to nearly every response, a sign that the preference signal is being gamed rather than truly understood. And there is a meta-concern the authors raise themselves. Making it cheaper to control model behavior also makes it cheaper to control it in pernicious ways. And reducing human oversight in training could let unforeseen failure modes slip into deployment. Now let's walk through some questions you might have after hearing all of this. Why does the supervised stage even matter if the reinforcement learning stage is doing the heavy lifting? The supervised stage is essentially there to get the model on distribution before reinforcement learning begins. Reinforcement learning struggles when the starting policy is very far from where you want it to end up, because exploration becomes expensive and unstable. By first fine-tuning on revised, less harmful responses, they give the reinforcement learning stage a much better starting point, which makes training shorter and more reliable. It is the difference between teaching someone to ski by pushing them off a cliff versus starting them on the bunny slope. How can the model critique itself reliably when it produced the harmful response in the first place? This is the most counterintuitive part of the method, and the answer lies in how language models actually work. Generating fluent harmful content and evaluating whether content is harmful are genuinely different skills, and the second one turns out to be easier than the first, especially when the model is prompted with a specific principle to check against. The paper's evaluation on multiple choice harm questions shows this directly. Even without any harm-specific training, large pre-trained models can identify the more harmful of two responses with accuracy approaching that of dedicated preference models. So the model is not exactly contradicting itself, it is using a different capability to check its own output. What happens if the Constitution contains a bad principle, or principles that contradict each other? This is genuinely a vulnerability of the approach. Because the principles are sampled randomly at each step and ensembled together, an individually bad principle gets averaged out somewhat, which is actually one of the benefits of using 16 principles rather than one. But if the Constitution systematically encodes a bias or blind spot, the whole training pipeline will faithfully propagate it. The authors note that the small number of bits in a Constitution makes it worth studying carefully, and they explicitly punt the question of who should write these principles to future work involving broader stakeholder input. For large-scale recommendation systems, the most direct lesson here is about scaling supervision when human labels are expensive or impossible to obtain at the volume you need. Recommendation systems serving billions of users face a similar bottleneck. You cannot get human judgments on every candidate item, every ranking decision, or every novel piece of user-generated content that might be unsafe or low quality. The Constitutional AI Playbook suggests a path where you write down a small set of natural language principles describing what good content or good recommendations look like, then use a strong language model to score candidates against those principles at scale. Then distill those AI judgments into a lightweight preference model that can run in your ranking pipeline. This is particularly attractive for harm detection in user-generated content, where the long tail of failure modes makes exhaustive human labeling impractical, and for policy enforcement, where the rules change frequently and relabeling massive datasets every time policy shifts is prohibitively expensive. The deeper insight for recommenders is the value of legibility. In a typical ranking system, the objective is encoded in a tangle of engagement metrics and learned reward models that no single person can summarize. Constitutional AI's approach of putting the training signal in a short, human-readable document means product managers, policy teams, and trust and safety teams can actually inspect, debate, and revise the objective without rerunning massive labeling campaigns. Combined with chain-of-thought reasoning at scoring time, you get an audit trail explaining why a particular item was downranked or promoted, which is increasingly valuable as recommendation systems come under regulatory scrutiny and as the cost of opaque ranking decisions grows.